pre-processing steps. So in pre-processing steps, basically you have majorly two, and you have something called promotional sales lift elimination as well. So we'll see first one. So important thing is you can only have pre-processing steps and save your profile, and you can run the forecast, means forecast job. That what will happen, only pre-processing step will happen in that forecast job, means statistical forecast will not get generated, but only outlier correction can happen. Okay.
Yeah.
Or you can only run forecasting, or you can only run post processing step, or you can run combination of two or all three also together. Okay, it's not like mandatory you have to select everything. That's an important thing. Yeah.
Okay. So basically, based on the requirement, we will have multiple models.
Yeah. So you'll have obviously you'll have lot of models. So one with pre-processing with substitute missing values. Okay. One with outlier correction. One with some promotional sales lift elimination, something like that. So obviously you can have multiple values. Also, I told you either you can have pre-processing, forecasting, post-processing, like that. Also individually you can have all three also. Means in the same profile also I can have all three.
Okay.
Means first substitute missing values will happen, next outlier correction will happen, next promotional sales lift will happen. So like that also can work. Okay.
Okay.
Okay, so you can create how many models you want. You can create that many models. There is no restriction, and you can run all of them and see which one suits you best. Okay.
Okay.
Just give me a second.
Sure.
Yeah. So let's go to substitute missing values. So substitute missing values. So now what I'm telling my system, you take 156 weeks of history. I'm telling system, right? Now in my 156 weeks of history, I might have some blanks in between. I discussed previously, like 1 week I sold 100, other week I sold 110. Next week I did not sell anything. After that I sold 110. Next week I sold 90. Again I did not sell anything, and then I sold 85. Okay. So this is my history pattern. Suppose this is my history pattern like this.
Yeah.
Okay. Now I'm having some missing values in between. Okay. Now system is asking you whether you want to substitute these missing values by anyhow. Do you wish to substitute these missing values? Okay. So there are various ways how to substitute these missing values. So first one is whether you want to substitute the missing values with mean. So what is the mean? 96.25, right? So if you select that option, these substitute missing values will be replaced with this is your actual history, right? This is your sales history key figure. In key figure it will not replace and save. Okay, internally it will treat these blanks as 96.5 in generating the statistical forecasting. So while generating statistical forecasting, it will read history like 100, 96.5, 110, 90, 96.85. It will not replace your sales history with blanks with 96.5. Okay. If you want to see these numbers in some key figure, you have to create one new key figure, like substitute missing value, one new key figure, and you can tell system to store these missing values in one. So then the substitute missing value key figure will be like 100, 96.5, 110, which you can see. Okay. But ideally, point is you should never change your actual history key figure. Okay. So this is how substitute missing value will work. Means it will replace your missing value with the mean. Otherwise, other option you have is given value. Means you can tell system given value. You can give some value like 900. Okay. Then what will happen? All blanks will get replaced with 900. Okay. Constant value, whatever you are given. Otherwise, you can tell system to calculate median. Instead of mean, you can tell system to calculate median. Suppose median is 85, then it will be replaced with 85 missing values.
Okay.
Okay. So mean, median, and given value. So three options you have. So it is asking you method used for substitution. What is the method used?
Okay.
Mean, median, and given value. So mean, I showed you. Median, system will calculate median similar way, and it will replace the missing value. given value. So given value, suppose if I give 900 here, so I'm giving 900 here, and in our history, if you remember, we have some missing values. Okay, let me load our IBP history. So we intentionally created some missing values, if you remember, right? So those get replaced with 900 now. So let us see that while we run the history. And what I'm telling, input for algorithm. So what is the input key figure? Actuals quantity key figure is our history key figure. Yes. Right. So I need to select my actuals quantity key figure. So I will type here this one, actuals quantity key figure. Okay. Yes. See, it is asking save result in. So if your company is having substitute missing value key figure, okay, then you can tell system save result in substitute missing value some key figure you can give, and you can tell your that you want to save the result. Otherwise, you can just leave this as blank. Okay. Now this is our I forgot what is our forecasting model. No, I think this one. No, that template what we created, right? Okay. Sorry. Yeah. So this is our history that day we created, right? If you remember, I think I have put some blanks. Okay. Okay. But or let us put some blanks now. Not an issue also. Okay. Okay. So let us make this one as blank. So make this one as blank. Blank. Okay, I will save now so that these missing values will get substituted with 900. So that's our assumption, right? So we can check that. Okay, you understood missing values? Any doubts in substituting missing values? No, we are fine. Okay, so next is outlier correction. So what is outlier correction? So in our history, we can have some outliers, right? So what is out? I think this Excel is. So let's wait for a minute so that it will get saved. Sure. Yeah. Yeah, it is saved now. Okay. Now coming to our history. Now let us think. So what is an outlier? Now my history is like this: 100, 110, 90, 85. Yeah. Okay, 89. So this looks good. Means consistently looking at it looks good, right? Now suppose if it is like this: 100 I sold. Next month I sold 900. Okay. Again I sold 10. Again I sold 560. See, if it is like this, there is lot of inconsistency in your history. Inconsistency means your history is not so consistent pattern. Means one week you're selling 100, next week you're selling so inflated 900. Yeah. Again, next week you're selling only 10. So if your history is like this, it is very difficult to predict the future forecasting, right? Because there is no pattern, and this 910 might be some outlier. Outlier means this week something could have happened. Okay, like suppose if you are running a canteen or something in a remote place, in this week someone a huge college came for picnic, so you got lot of sales. 900, so you sold. Next week it rained fully. Normal people also did not come, so nothing got sold. So only 10 you sold. So like that, it is varying so hugely. So then it is like you have some outliers in your history, okay, because you are having here and there. So then what you can tell system, so system will do some calculation, it will do some standard deviation calculation and other formulas, it will do something. And what system will try to do, it will try to create a tolerance bands. Okay, so it will create two tolerance bands. Okay, so like so it will create two tolerance band one like this and band one like this, literally like this. Okay, so it will tell tolerance band one is like suppose 110. Okay, and tolerance band this is 50. Okay, so what system will do is anything below these tolerance band, it will treat as a normal history. Okay, means 100, it will treat as a normal history. Okay, 10, see beat is below 50, so it will treat as a outlier. If it is above 110, it will treat as a outlier. Okay, so it is treating 90, 110 as outlier, 560 as an outlier, 80 as a good history. It is treating 80 as a good history. So like this system will detect what are the outliers. Okay, you understood this till here?
Yeah, I get it.
Yeah. So once system has detected outliers, so system is asking what you want to do with these outliers. How do you want to correct them? Okay, so that is what here. So first, what we are telling, outlier detection method. Okay, means first system should detect the outliers, right? So to detect the outliers, there are two methods here. One is IQR test. Okay, interquartile range test. So this is what I told you. System will calculate the tolerance bands. Okay, and second one is variance test. So variance test also basically system draws the tolerance bands, but this band limit will be little less. Okay, like here basically it will use some variance formula. Here it will in IQR test it will use standard deviation formulas. Okay, I'll send you one document. You'll have all the statistical formulas in the document. Not necessary to know, but it's good if you can just go through that them at once. You don't need to buy at them or no need to. Yeah, because they're very complex formulas, but you can go through them once. Okay, and multiplier 1.5 is standard multiplier what we give. Okay, it is so what will happen means this outlier is detected, right? Then then system will multiply that outlier with 1.5 factor just in case. Okay, I mean you can change, you can tell one means whatever system calculated outlier, it will be same outlier. Now why I'm giving 1.5? Now system calculated 110 as my band, right? Anything above 110 as my outlier. Now if I give 1.5, system will increase the limit little bit. It will tell 120 is my band, 120 to like 40 is my band. So if I want to increase that limit band, so you can give the multiplier more or less. So 1.5 is the SAP suggested value. So if you want, you can leave it or you can change 2, 3, you can change whatever you want. So with this outlier detection method with IQR or variance, whatever method you select, system what it will do, it will just calculate the outliers. So once system has calculated the outlier, now what you want to do with those outliers? No correction means it will system will not do any correction. It will leave as your history as it is. Means in calculating forecast, it will read this as only your history. Okay. If you suppose if you give correction with mean, so what will system will do? It will calculate the mean here. Same thing like substitute missing value. What is the mean here? 330. So it will replace these outliers with 330 while calculating the statistical forecasting. So it will read 900 as 330, 10 as 330, 560 as 330, and this is 80, and it will generate the statistical forecasting. Okay. Understood? Next method is correction with mean excluding outliers. Means what system will do? It will exclude these outliers and it will calculate the mean. So what is mean? For these two, it is 90, right? 100 plus 80 is 180 by 2, 90. So it will replace these outliers with 90 now. So this looks ideal correction. Okay, for any correction, this looks bit ideal, right?
Okay.
Otherwise, same again with correction with tolerance. Okay, it has drawn some tolerance band, right? So it is asking whether you can correct with tolerance. Now here 110, it will tell 900. This has 110. Okay, this has 50 tolerance because it brought the tolerance 50. Like that, some tolerance band, whatever tolerance band it calculated, it will correct with that tolerance band. Okay. Otherwise, it is asking correction with median. Same like here, what we have mean, median. Now here also system will calculate median of this series and it will replace with median. Otherwise, you can tell calculate median excluding outliers. Means it will calculate median only for these two numbers. It will be median will be same 90 only, right? So 90 it will replace with this outliers 90, 90, 90. Okay, so like that we are telling system how to correct the outlier, like no correction. So I'll tell correct with mean to calculate the outlier. Let us see what will happen. Okay. Okay. So consider time series properties. This is one specific concept again. So we will discuss this separately. And remember, here we have this indicator. Remember, for life cycling, we have the indicator here. Like that, you have consider time series properties indicator also here. Yeah, yes, you have. Now again, it is asking what is the input algorithm. So input algorithm is this actuals quantity, right?
Yes.
So actuals quantity. Okay. Okay, I think it's asking. Yeah. So promotional sales lift elimination. So in your so here what is that? If you are using some promotional planning in your IBP, means you have created one promo key figure. Okay.
Yes.
Then what you'll have, like this is my actual history key figure is like this. Okay, 100, 110, 150, 80, like this. Now I have one more key figure called promo key figure, means promotions. Means in this week I have given some promotional offer, 1+1. Okay, so 50 quantities got more. Okay, in this week I gave some offer again, so 100 quantities got more. So what is my actual total actual 100, 100, 160, 150 and 190, right? So my actual quantity is more now, right, in few weeks. Now, if you want to remove that promotional influence from your history, then you can use this promotional sales lift elimination. Okay, means it is lifting the sale, it is eliminating the sales which are caused due to promotion. Okay, ideally, not many companies are using this because no one is using promotional planning in their company. Even we are not using. But if you are using promotional planning in your company, any chance, if you go, then here you have to select the key figure where you have this sales lifts. Okay, where you have this sales lift elimination. Okay, and you can tell system like that is the sales lift what you want using, and you have to give your consensus forecast key figure is your final demand key figure. We will see this again, but just remember consensus forecast key figure is your final forecast key figure. So you have to give that key figure and you have to select this sales history and promotional sales lift. Okay. So if you want to use this, then you can use this one as well. If you are using only promotional planning, otherwise you shouldn't be using this.
Just a small thing. I mean, how to check the fields? Technical. I mean, in normal SAP, if we have F1 to check the technical properties or.
Oh no, we don't have such. No, we don't have anything here. But there is something called question mark here. Okay. If you select this, it will just show some help. Actually, it will take you to SAP help. Like if I click this, it will show me. So in SAP help, what all are there, right? It will just show me. But there is no F1 concept and where you can see like that. It is not there.
I guess this is what I expected. So I guess this is fine. It's still mentioned like why it is used, right? Here.
Yes. So it will tell, like if you go, it will tell what is outlier correction, what is substitute missing alias, what is promotional sales lift elimination. Like that, it is telling you little, right? You'll have, if you want detailed information, you can click this. It will take you to SAP. Yeah.
Okay.
It will take you to SAP help, and here you have more information. Like again, here see, they have given lot of information here.
Lot of information, from SAP help. Okay.
Yeah. So SAP help is always there. You can go here. Here you will get again detailed explanation about everything, like why it is used, what it is there, what are the types, like mean, medium, what it will do, even value.
I get it. I mean, all the time we can't remember all of these values, right, while working. So sometimes, like as you said, like the promotional planning, like suddenly it pops up in work means probably we just need some additional help, right? So.
Yes, exactly. So here, if you go for outlier correction, they have explained the formula for interquartile range also. See, it will split the data into three quartiles basically, Q1, Q2, Q3, and IQR is Q3 minus Q1. Okay, so how Q1 is calculated means, first you have data series like this, right? You have data series. So it will check lowest 25% of data. Okay. So it splits the lowest 25% of data and it will put them in one band. Okay. And Q3 is the highest it will split. And Q2 it will just split half and half. Okay. Like when you're calculating median, how you do similarly. So next you have given some multiplier, right? With that multiplier, it will multiply and it will form lower bound and upper bound, like lower tolerance band and upper tolerance band. So like that it will calculate in interquartile. In this variance test also, see, it is what it is doing, it is calculating mean. Instead of it is here also it is calculating lower and upper band. But here what it is doing, it is forming some quartile ranges, right? Like up 25% lowest, 25% highest, it divided and it is generating something. But here it will simply calculate mean minus multiplier into standard deviation, it will take into consideration. So multiplier into standard deviation mean. So like that, lower band and upper band it will calculate again here. Okay. Like that, like this it will, like if you see the graph here. Yeah, if you look at this line, this is this red line and this red line, this is the range. Okay, anything. So this is an outlier, this is an outlier, this is an outlier, this is an outlier, like that. Yeah.
Correct. Yeah.
Okay, I think they have given clear explanation what will happen based on what you select here. Okay.
Yes.
Yeah, so that's so again we can select one algorithm, or you can select two algorithms or three, or you no need to select anything also here, and you can just skip this one as well. Okay. So
yeah, sure.
You understood this pre-processing steps?
Yeah. I have some idea now.
Okay. So next, coming to forecasting steps. So in forecasting steps, what will happen? So first you have to give what is your forecast input.
Yes.
So what is my forecast input? Actuals quantity. Target key figure means it is asking in which key figure you want to see the forecast results. So if there is some key figure called statistical forecast quantity key figure. Okay. So in this key figure, I want to see my statistical forecast. It is also asking, if you want to see exposed forecast, what key figure you want to have. So if your company, if you want to see exposed forecast, then you can select. But what is exposed forecast? Now this is my history, right? Suppose now I'm calculating forecast. Now system will calculate forecast and suppose it is telling like this 100, 100, 100, 110, like this. It is showing forecast. Okay.
Yeah.
So how system will actually predict this calculation? How system will actually calculate? So basically what system will do, it will start calculating forecast in the past also. Okay. And it will continue this series into future like this. But in the past forecast, you will not see ideally. Okay. That is system internal calculation. So that calculation is called as exposed forecast, means forecast in the past periods. Okay, what system is that? So if you want to see exposed forecast, means if you want to see how system calculated in past forecast, means the system can calculate 90 here. Okay. So system will try to match your history pattern, right? Always. Your forecast should match your history pattern. So system will try to match this history pattern. So it will calculate the exposed forecast. So based on that exposed, it will calculate the future forecast also. So this is called as exposed forecast. So if you want to save or see that results, you can create one new key figure in your planning area called exposed forecast, or SAP default also has given exposed forecast, I think. Since we copied planning area from Unipa, right? You will have exposed forecast.
You have it. Okay.
Yeah, you can just save this, then system will show exposed forecast quantity also. I think you'll have substitute missing also. Yeah, substitute missing values is also there. Because we copied from Unipa planning area, you get this all standard key figures.
Standard key figures also. Fine.
So one, you can give actual quantity or statistical forecast quantity. Okay, I mean you have to give these two key figures, and next you have to choose the algorithm. So this comes the important step of statistical forecasting. So you have to click this, and we have all these algorithms in IBP. Okay, means these many statistical forecasting algorithms I have, and I have to know which one I have to use. Okay, like you can use if you know which one you have to use, then you will get the correct forecast. Okay. Okay, so there are some auto models also. So if you don't know which one to use, you can select auto models, which will help. Which system only will do lot of iterations, and it will give you best forecast, like auto arima, auto arimax, automated exponential smoothing. Okay, but before going this auto models and anything, let's simply understand few things. Okay. So simple average, simple moving average, weighted moving average, and Croston method. Okay, so these five, let's simply understand here. So simple average forecast, if I'm using, it simply will calculate the average here. What is the average? 108. So it will generate my forecast as 108, 108, 108, 108 across my 2 years of my history. Okay. So that is simple average. Simple moving average. What will happen? What is the average now? 108, right? So it will put 108 in first bucket. Next, what is the average now? 109.6. It will put 109.6.
Okay. Okay.
What is the average now?
111. Oh, for the
111.52. It will put 111.52. And what is the average now? You are understanding what I'm trying to do here? It is moving.
Yes.
Yeah.
I'm getting
it. Will put 111.9. So it will calculate. So we have discussed two forecast methods already. Simple average, it will just calculate the average. Simple moving average, it moves on and it calculates the average.
Yes. Okay.
Okay. So weighted average. So in weighted average, you can give weights. Okay. Means you can tell in my recent history, you can tell consider 90% of my recent history. Okay. And in past, you consider only 50%. Okay. Why like this? Because recent history is always good history. So you want to consider system more good history. So 80 quantity of 90% is what? Like some 70, let us think. Okay. So 70, 140. So system will treat this is my history, 100, 55, 50. So system will treat this as your new history, and like based on this, it will calculate your forecast. Okay, based on this. So okay, based on the weights what you have given. Okay, that is weighted average. Weighted moving average means same weights. It will keep on shifting, like simple moving average, right? First, it will calculate the forecast with weights like this. Next, it will calculate forecast with weights like this.
Okay, until the history.
Until the end. Yeah, until the end of forecast horizon.
Until the end of the forecast horizon itself, the moving.
Yeah, because it needs to calculate forecast right till end, not until till history. Yeah.
Okay, that means from today to forecast horizon, it will be of blank, right?
Yeah. Yeah. No, see, in simple moving average, for second bucket only we crossed history.
Yes.
Oh, you are telling this one, right? Yeah. Yeah, until the not for means what I'm trying to say. Yeah, I understood your question now. See, our history is 3 years. Our forecast is 2 years only, right? So it will not complete even history until history. 2 years of history, it will go forward. You understood? Like see now, I'm how many periods of history are there? 5 periods. Suppose I'm telling system calculate forecast only for 3 periods. Okay, 3 periods.
Yeah.
Then system what it do in first period, what will system will do? This it will put 108.
It will put 8. Yes.
And second period, what system will do? It will put 109.6.
Oh,
right?
Sorry. Considering the forecast value, the moving is.
Moving will happen.
Okay. Got it. Now got it. Yeah. So moving is, it doesn't depend on the history of forecast. Once like the new forecast values created, that is also considered for the moving average.
Yeah.
Okay,
For
okay,
moving,
okay.
it keeps on moving further. Okay, until the end of forecast periods. Means how many forecast periods you're asking system to calculate. Till that it will go on and it will go. Okay.
Okay. Yeah.
And Croston method you will use that specific method when you have lot of blanks in your history. Okay, means if you are not using substitute missing values and outlier corrections, if you left it like that and you have lot of blanks in history, means you have history, you're selling one day, not selling one day, again you're selling, not selling, like that, then you use cross-check method so that it will try to eliminate those blanks and it will try to give you a better forecast. Okay. So like that, every algorithm is having a meaning. Okay, so let's quickly go through Okay, simple moving average we already discussed. So simple exponential method. So simple exponential. So again, coming to our history pattern. So there are two things. Okay. One is normal history, like this you have. Otherwise, your history can have seasonal pattern. Okay. Your history can have trend pattern. Okay. So what are these? So seasonal pattern. Suppose I am doing a umbrella business. Okay. Means in rainy season, my sales will go very high every year. Right. In summer season, my sales will drop by huge margin. Right. Or in winter season, my sales will drop by huge margin. Okay. So whenever I'm calculating my forecast in future 2 years, in the rainy season, it should give me more forecast number, and in remaining months, it should give me less forecast number, right? Yeah. Because that's my business, right? So if I tell system to consider seasonal pattern in my history, if I'm telling system to check for any seasonal pattern in my history, then what will system do? System will check if you have any seasonality in your history, and accordingly it will generate your forecast. Okay, it will check if there is any, if it found any seasonality. So to find seasonality, system has some parameters and some formulas. It will try to find some seasonality in your system. So based on your history numbers. Okay, so based on your history, it will try to see if you have any seasonality pattern. Okay, so if you have some seasonality, then it will give your forecast account. Like that trend. Like suppose either it is increasing trend or decreasing trend. Now you started business newly, so every month you are having good increase, like 110, 112, 115. Like every month you are expanding, your business is expanding, so you are seeing an increasing trend in your forecast. Right. So there is some trend pattern, either increasing or decreasing. There is a trend pattern, either your sales are going like this or your sales are going like this. It is not constant, either they are going like this or going like this. So there is some trend pattern in your history. Okay. So system, if you, so you have to first understand what is your history pattern. Okay. Means whether my history have seasonal, then I have to use forecast algorithms which are applied for seasonal forecasting. Okay. If I think my history pattern is having trend pattern, I have to apply algorithms which have some trend patterns. Okay. Now we're coming to the algorithms. So single exponential smoothing you have to use when you don't have any seasonality or trend patterns. Okay. Means your model doesn't have any seasonality or trend pattern, then this algorithm is best to use. Okay. Means if you have only some fluctuations and you don't have any these kind of patterns, if you think you don't have, then you can use this algorithm. If you have trend, what you have to use? You have to use double exponential smoothing. Okay, you have to use double exponential smoothing if you have trend, not seasonality. This is wrong. I'll just update this. So if you have trend, you have to use double exponential smoothing. Okay. If you have seasonality in your forecasting model, then you have to use triple exponential smoothing. Okay, so you're clear till here. Just understand here. Yeah, if you don't have trend or seasonal, you have to use single exponential. If you have trend, you have to use double exponential. If you have seasonal, you have to use triple exponential. Okay.
Okay.
So now there are some smoothing parameters which are very important to understand, and this is basic question in any interviews. Okay. So smoothing, what are the smoothing parameters we have? We have alpha, we have beta, and we have gamma. Okay. So alpha is a smoothing parameter uh, for data variations, we can say. Okay. Beta is a smoothing parameter for trend. Okay. And gamma is a smoothing parameter for seasonality. Okay. So if I'm using, so alpha is common in any forecasting profile. Okay. I mean, you use single exponential, alpha is a mandatory parameter. You use double exponential, you'll have alpha and beta. You use triple exponential, you have alpha and gamma. Okay. Okay. So what does alpha mean? Now, now Now let us think my history pattern is like this. Okay, let us think my history pattern is like this. Okay, and I'm now trying to calculate forecast. Okay, now what will happen is when I'm trying to calculate forecast, okay, when I'm trying to calculate forecast, so what is alpha? It will check for my data variations. Means it will check how good it will smooth my data variations. Means it will check how my data is varying over the cycle or the history period. Now suppose if my alpha value is very less, okay, then then my forecast can't react to the data variation. Means my forecast will be like this. See, it is not able to react. It is trying to react, but it is not able to meet. Now, forecast has fallen. History has fallen, but forecast will take time to fall because it is unable to react quickly to my history variation. Okay. Ideally, alpha 0.3 is a suggested value from SAP. Now, if I given suppose 0.8 alpha means I'm able to react to my history variation properly. So my forecast will be like this also. Means it is able to react almost to my data variation like this. Okay. My forecast will be like this. Okay. So based on alpha, you can see how my forecast is varying. Okay. So like that. So if someone asks what are the smoothing parameters, you have to tell alpha, beta, and gamma. Alpha is used for data smoothing in the data variations. Okay. Beta is used for variations in the recent data, recent buckets. Okay, so beta is used for smoothing trend factor. So obviously, similarly, in recent buckets, in the recent history buckets, it will try to smooth the trend factor. Means how much trend is there, how much to react to the trend values in recent bucket, like that. Seasonality also same. It is a smoothing factor for seasonality. Okay, so these three are very important concepts. So that's the same thing what they're mentioning here. Single exponential smoothing, it is used when there is no trend or, and they are telling a number alpha is used here. Okay, alpha coefficient is being used. And there is something called adaptive response rate, adaptive response rate single exponential. So in this forecasting algorithm, what will happen means in single exponential smoothing, you have to give the alpha value like 0.3, 0.5, 0.8 you have to give. In this adaptive responsive rate, you can give one value like 0.1. System only will keep on incrementing alpha by 0.1. Like it will check for 0.2, it will check for 0.3, it will check for 0.4, and it will see which alpha you are getting a good forecast. System only will check and it will give you the best forecast. Okay. In double exponential smoothing, you have to give the trend beta value. Beta is trend. Okay.
Yeah.
Very important. They'll ask why beta is used. You have to tell trend smoothing. Okay.
Okay.
Gamma is for seasonality smoothing. Okay.
Okay.
Okay. If you're using triple exponential, then it is you have to give gamma. So this is weighted average, weighted moving average, and cross-turn method. Okay, you can go through this. I'll send this PPT to you later.
Sure. Okay.
Automated exponential smoothing. Now in this automated exponential smoothing, it only calculates all. Now single exponential, double and triple, what we saw here. Single exponential, double exponential, triple exponential. In automated, what system will do? It will only calculate your alpha, beta, gammas. It will only try to identify alpha, beta and gamma. Okay, it will only check whether you are having trend pattern, seasonality pattern or not. So based on this, see this diagram here, it will check for trend and seasonality. If you don't have anything, your automated exponential smoothing will run single exponential smoothing. Okay, means it is only selecting which exponential smoothing out of single, double, triple. If you don't know what to use, you can select automated exponential smoothing. System only will try to choose which one it has to run. Okay.
Correct. Okay.
Similarly, we have ARIMA model. So in ARIMA model, what system will do, like lot of regression happens here, and you have to be very careful not to use this algorithm for larger set of data. It runs for longer run times. Okay, because lot of regression happens. So here, what is this auto ARIMA? Auto regression. Okay, integrated moving average. So basically, moving average here. Right, moving average, but some auto regression integrated moving average. So 3 steps basically this algorithm gets splitted into. So just at high level understanding, you need to have like what these algorithms does. Basically, a lot of statistics formulas are involved backend, but just at least we need to know what this algorithm basically does. Okay. So in auto regression, what does algorithm does? In differencing, what does algorithms does? In moving average, what does that algorithm does is given here. Okay, like in auto regression, what happens is, so what will happen in auto regression is, where is our data? So you have history pattern like this. Like suppose you have for January, you have for February, you have for March, you have for April, like this. So in auto regression, in January 2022, it is 100. So system will check what is in January 2021, what is in January 2020. So it will check all these history patterns like this for each bucket in past year, how it was. Okay. So it will do some analysis based on, it will calculate some values based on that number. Okay, means it will see how your forecast is varying in your past buckets. Means how you have done, why basically, if there is any seasonality or trend, also it can understand from this, right? If it is doing like this. In January 2021, you have sold 100. How did you sell in January 2020? I mean, did your sales increase? Are you having some trend pattern? Or is your January sales are high? I mean, are you have some seasonality patterns? Like that, it will try to it will do some regression here. Okay, after that it will do some differencing. So there is something called stationary value and non-stationary time series. Then what system will try to do is, it will try to calculate where is our history pattern. It will, so system will try to determine some stationary and non-stationary values, means values which are moving or changing, and values which are not changing a lot. Okay, like suppose 100, 100, 100, 100, 100, my history is there. It is a non-stationary value history. Now 100 I'm having, 150 I'm having. So 100, 100, 100 if I'm having, that's a stationary history, right? Non-stationary means if I'm having 100 in one bucket, I'm having 900 in other bucket, or some change is happening. Non-stationary means my history is varying a lot. So it will try to calculate some differences between those things. Okay, and after that it will do moving average based on everything, and it will give a forecast based on all these calculations. Okay, so it will take a lot of time. It's a time taking forecasting, and we have to be very careful while using this. And also it has some disadvantages, like it takes time. And also it requires large amount of data. Why it requires large amount of data? So I already told you, it will take January 2021 100. It will compare with January 2020. It will compare with January 2019. Means at least 3 years of data you should have for good Arima forecast. If your product is having only 1 year of data or 6 months of data, if you are using Arima, it is waste. It might not give you good forecasting. Okay, like that, it is not used for intermittent demand. Intermittent demand means cross-trend demand is the one which you have to use. Intermittent means you are having some blanks in between. And if you're trying to apply Arima to it, then again also it will give wrong forecasting because it is comparing, it is calculating some differences and all. Then if you have some blanks in between, it will go haywire. Right, so you should be careful while using Arimax that you are not using in these kind of scenarios.
Okay.
Okay.
Mhm.
Okay, here I have given what is alpha, beta, and gamma also specifically. You can go through this document.
Okay.
Yeah, we have one more called phi coefficient. So phi coefficient means if you have, if you want to damp that trend pattern, means you are having some trend pattern, and if you damp it means reduce the effect of the trend pattern. Okay. Then you can use phi. Okay, phi coefficient. So these actually phi coefficient, I'm not sure, most of them may not ask, but alpha, beta, gamma is a common interview question. I mean, even if you don't get in one of the interview, other interview, you will get someone asking this question.
Okay.
So just both. So now we have, so at a high level, we have gone almost all these algorithms, okay, like weighted, moving, automatic. These one, so copy past periods is just copying whatever history is there into your forecast buckets. Okay, just copy past periods. Means whatever is there in history, it will just copy. Okay. So so suppose now you're new, you're a demand planner. Okay, means business user, and you don't know anything about. Ideally, these demand planners needs to have this statistical knowledge of these algorithms. Now, suppose you have joined and you don't know anything. Okay, then what you can do? You can select multiple algorithms. Okay, you can select auto Arima. You can select triple exponential. You can select average. You can select like this multiple algorithms. You can select. You can select weighted average. In fact, you can select all available algorithms. Okay. You will select and you will tell system to choose best forecast out of these all models. You will tell system you only choose best forecast. Okay. Based on what? Based on the error, forecast error. So whichever forecast algorithm is giving least error, it will choose that. And you can choose what error you want to measure also. So normally MAP is the best measure what everyone will like because it will give a absolute percentage error. Okay. It is it's an absolute means there is no negative, and on top of that it gives a percentage error also. Okay. So mean MAP is a favorite error for many companies. Many companies use MAPA. So if you are giving MAPA, so whichever algorithm is giving me least MAPE, system will choose that as my best forecast. Okay. And that algorithm system will choose as my best forecast. Alternatively, I can tell calculated weighted moving average. Means I can tell system use whatever auto Arima generated. You take 70% of auto Arima. You take 10% of triple exponential. You take 10% of simple average. Like that, I can tell system. Okay, I can weigh also. Okay, otherwise I can tell choose best forecasting model. Now in weighted average, if you go see, it is telling me source of weights. So you have to create one key figure. I told you right here, it will weigh. Like I'm telling, consider 80% here, 90% here, 90% here. Consider this history 60% only. So where this weights 60, 90, 90, you have to create one weight key figure, and you have to give those weights in that key figure, and you have to give that weight key figure source here. Okay. You can give that weight key figure here in weighted average. You have to just select what is the target key figure for forecast. Similar to here, you have to give same key figure, statistical forecast. Similar to here, same key figure, whatever you are giving exposed forecast, you have to give here. In simple average, it is simple average. You are just giving target forecast and target exposed. Because simple, average is nothing, right? System will calculate just the average, no parameter. In triple exponential smoothing, see, triple exponential smoothing, what I told you, it is a seasonality model. What is the seasonality here? Alpha and gamma. So if you see alpha and gamma, they are marked with star. Like it is important, mandatory to give. Beta, if you see, it is not marked with star. Means even if you don't give also, it's okay. But alpha and gamma, you have to give because this is your seasonality trend pattern. So it is asking how many periods might be in a season. Suppose if you have 4 periods in a season, if you think, then you can give 4. So that system will break your history into 4, 4, 4, 4, and it will try to do some regressive testing and it will try to detect that. Okay. Enable trend dampening. If you want to do trend dampening, as I said, phi coefficient is for trend dampening. So if you want to do some trend dampening, you can use phi. Okay. Again, you have to give target key figure here. So similarly, like that, you can, if you want to select double exponential smoothing. In double exponential smoothing, you don't have gamma only. You saw, because double exponential smoothing is only for trend. In trend, you have beta. Trend is for beta, right? So double exponential, I told you, alpha is common for everything. Alpha, and here you have beta. Okay. So you just need to give alpha, beta, and the key figure for storing statistical forecasting in double exponential smoothing. If I'm choosing not adaptive, I'll show you automated exponential smoothing. If I'm selecting automated exponential smoothing, see here it is asking lower limit for alpha, upper limit for alpha. Means it keeps on incrementing. Now I'll tell 0.1 to 0.9. From 0.1 to 0.9, it will only decide what is my alpha, what is my gamma. It will keep on testing with 0.2, 0.3, 0.4, 0.5. Then it will see which is good forecast. Okay, which is giving me best forecast. Based on the error measure again here. So I will tell MAPE is my error measure. Then system will do all that test, and if 0.5 alpha, 0.4 beta, 0.3 gamma is giving me least MAPE, it will select those parameters and it will run the triple exponential smoothing because all 3 parameters are involved. Right? It will check whether you have seasonality, it will check whether you have trend, it will check. If you have seasonality, it will run triple exponential. If you have trend, it will run double exponential. Okay, like that, this automated exponential algorithm will work. So like that, you can give multiple algorithms. So what I'll do now, I will select all these things. Okay. And I'll tell system to choose best forecast on MAPE. Okay. And in post-processing steps, MAPE is defaultly clicked and I can't untick this. It is disabled. Why? Because I have selected here MAPE. Means MAPE is mandatory. You can't escape that. Okay. In post-processing steps, you can select what all errors you want to calculate. I want to calculate only MAPE. If your company is interested in other errors, you can just tick them. If you want to see the errors also in planning book or somewhere, you can assign the key figures. If you have the key figures created. Okay, like you can see key figure. If you create key figures, you can, I think since we copied our again standard planning area, there are some key figures like MAPE. So if I give this key figure, my error will get stored in this key figure and I can see this. Okay. So now I can save my forecast profile. So there are some errors it seems. Okay, I'll remove weighted average because I don't have weights now to give. Okay. Yeah, it got saved now. So now we have created the forecast model now. So what is our forecast model? Test demo something. Test demo 001. Yeah. This is our forecast model. Okay. Yeah. And we told calculate. So now I'm going to my planning book. Okay. So in my planning book, now this is my history. Right. Already we have seen our history. Yeah. Actuals quantity we loaded that day. So I will go to statistical forecast view, which I have created. Okay. So in your company, you might have this view or you might have everything in one view also. Like in sales history view, you might have means they will not call sales history. They'll call as demand view. Okay, means all key figures in one view. So I just created like this for my convenience. I'm just showing it. Okay. So I'll go here and I will load my data so that, and I will run the statistical forecasting. So this is our filter, correct? Looks good. I have to select the correct target EOM.
Yes. Each.
Yeah. So I have my actual quantity, exposed forecast, statistical forecast. So I'll remove exposed forecast and I'll keep only statistical forecast.
Okay.
I'll also remove this key figure. I'll remove this key figure. Okay. So I have a better view now. Like I have, and I will change this to weekly buckets because we are generating forecast in weekly buckets, right? So yes. I'll go here. Here, what I have to do, I have to select week. Okay. Instead of 2026, I'll just give
23.
24. So that till end of 23, I'll be having. Right?
Okay.
Okay. So I have one blank in week 15. Okay. So this should get replaced. This ideally will not get replaced with 900. But while calculating forecast, this should have been replaced with 900. Okay. It will not replace with 900 and save here. Okay. So let us run this and see what is happening. Okay.
Okay.
So to run the statistical forecasting, how I can go in Excel, I can go here, run application jobs, run statistical forecasting here.
Yes.
Okay. So I will go here. So you can run statistical forecasting from Excel or from Fury also. So if I want to run from Fury, what I have to do, I have to go to the application jobs app.
Yeah.
I have to select the template statistical forecasting. I have to fill the template and just run the job. So this is same for any job in IBP. You have to go to application jobs. You have to click create. Okay. Once you click create, you have to select your template here. Okay. So now what we are trying to do, we are trying to do stat forecasting. So just type stat, you'll get statistical. So just select this. Then step 2, scheduling. You want to run immediately, you can just start immediately. Step 3, it will ask some information to fill. You have to fill and run it. Okay. So same information we are getting in our Excel also. Okay. So I'll stop here and I'll move to Excel. So I have clicked run. So once I click run, this has come. So I want to run statistical forecasting at product location and customer level. Okay, doesn't make sense to include product description. So I will run at this level. Okay, I want to run in week. Okay, and it is asking me forecast model to be used. So what model I want to use? Test demo 001. This is what we have created. Right. So I will give this in it and I have to give my target UAM as HS.
Yes.
Okay, I'll give this one here. Okay, and my scenario will be baseline, version will be base version. Scenarios we have not discussed, I'll discuss with you, but for now scenario will be baseline, version is my base version. Okay, filter.
Okay.
So I have to give my filter here. So my filter is this one, product location customer, and I'll click next and run. So reason code. So you can just click this or just leave it and click run. So reason code is like why you are running this. If you want to give any reason, then you can select some reason. Okay. Okay, now it is telling job schedule. Okay, now you can check the status here. Go status, statistical forecasting. Then you can see the status.
Okay.
See, it is telling it is running. Okay. So you can check this even from Excel also. In Fury also. So in Fury, if you go and click like this and just check by your name, there will be one job running. See in process. See, it is telling test demo 001 job number planning area. Okay, scheduled. And you can just check from here. Click go. Then it will tell it is in progress or whether it is finished. You can check. See, it is showing a detailed system log. Okay. So first what we have done, we have told system to substitute missing values. So what system is telling? 2 missing values were found for system. Okay. So in these 2 missing values, for one combination means for this customer, this location, this product, 2 missing values were found. Again, for this location, this customer, this product, 1 missing value was found. Okay, it is also telling in which period it was found. Okay, it is telling in week 21, 2019, it was found. So it must have replaced with 900. Okay, wherever it has found missing values, it might have replaced with 900. Okay, so after that, what is happening? Step 2 of pre-processing step. In step 2, what it is trying to do, it is trying to calculate outliers. Okay, so it is telling no outlier, no outlier, no outlier, no outlier, because we have given good amount of range, right? So no outliers have come. Okay. Now, if I give some 1 lakh or something, probably it would have detected some outliers. But anyhow, no outlier, no outlier, no outlier found. After that, what system is doing? It first it generated triple exponential smoothing. Okay. After that, it generated simple average for all the combinations. It is generating triple exponential, simple average. See, it is calculating MAPE for all combinations, and it is showing what is the MAPE. Now, if I just make this one product, okay, and one location and one customer. Okay, now see what has happened. Missing values went after missing values. Outlier, no outliers were found. See, triple exponential smoothing MAP is 141. Simple average MAP is 124. Double exponential smoothing is 137. Automated exponential smoothing is 130. So which one is good? Simple average is good, right?
Yeah, less
telling simple average was selected. Lowest MAPU was 124 and simple average was selected. So system is only calculating what is the least error you will get, and that least error it selected for customer 1, question 1, product 1. So like that it will vary for customer product 2. Suppose we check. Okay, here you see triple exponential is 191. Simple average is 190. Double exponential is 183. Automated is giving you the least 168. So what must have selected? Automated exponential smoothing was selected. Now, if you are individually running statistical forecasting, it is very difficult for you to analyze these things and give the parameters, right? So here system only selected what is the best alpha, best beta, best gamma, and it has given. It has selected exponential smoothing, which is best, which is giving least error. So system only has done that. Okay. So let's see the values of statistical forecasting also. So if we go little front till 2022 buckets. Okay, it should have calculated forecast for future 2 years. So from here, so let's go here and refresh. Then it will show the forecast.
Okay.
Yeah, you saw forecasting. I think current week is week 17. So it calculated from week 17. Okay, week 17, all stat forecast it calculated.
Okay.
Yeah, you got this?
Calculates as 0 also.
Where?
No, there is some zeros, right? So so
calculated complete 0. So let's see customer 3, right? Why it calculated 0? Let us check it out. Oh, 1 second. See here you are getting like this, right? Product again. This product is not getting repeated. Okay.
Yeah.
Then how do you? I mean, this customer 2 line also product 1, customer location 1, customer 2, but this is not coming. So when you put filter, right, it will not show correctly. So what you have to do, you have to repeat these headers in order to get that. About settings options. Formatting, repeat row headers. Okay. So if you do this, okay, now you can put filters and it will show nicely. So I think we were checking for customer 3.
3, yes.
I forgot what is the product, so I have given customer 3 and
Product 1, I guess.
Yeah. So this one. Product 1, location 2. So let's again say it's product 1.
Okay. Location.
Okay. So this has given zeros across. So let's see why maybe because recent buckets are zeros, right? Probably it could have triggered that. Okay. So we will rerun the statistical forecasting by giving recent buckets also some values. Okay. And let's see. But let's see in the forecasting log what could have happened. Okay. So that is product 1. Location 2. And customer 3. Okay. Yeah, so it selected this automated exponential smoothing and probably it has done something. So what we will do now, so just select the access quantity and give some values here.
Okay.
Like 5,000 I will give across.
Oh, it was blank actually.
No.
Okay, this is on the focus.
Till week 17 we have to get it.
Oh, okay.
Okay. Suppose here I will give one very huge number so that it will detect as an outlier. Okay.
Yes. Venkat, also just a small thing. Later in our sessions, I mean, when we near to complete, so that time will you just highlight on the interview questions and the support point of error handling also?
Sure.
Yeah, I'm not sure. Like it's already included in our agenda, so I just wanted to highlight.
Yeah, sure.
Yeah, because I'm not sure. Like I mean, maybe support also can happen. I mean, how is the scope for support with IBP in general?
Yeah. See, whatever project they're implementing, they'll obviously need some team to support also, right? So,
correct. So the size would be like, is it less or how when it compares to APO? Because I guess in my current project, it's a pharma industry, so they would need at least some 20-25 people altogether from level 1 to level 3 for APO.
IBP support is less when compared to APO because in APO everything IT team you have to do, right?
Yes,
in IBP everything user only is doing now. Lot of things.
Okay,
Demand planner only he is only running the job from here. Okay. He can only go and create the statistical profile. In our company, they are only going and creating profile. Okay. They are only creating, maintaining master data, planning objects also they are only creating. Okay. So when they are coming to us, like we saw zeros now, right? So when there is that zero, they are coming to us and asking why it generated zero. Okay. That time we'll tell some parameter this one, or you choose this forecast model, choose some other forecast, or we'll tell there is history missing. That is why probably got zero. So like that it's like it turned out like that. Okay. So not much in count, but at least there will be a support tool also, right? Yeah. There'll be a support for sure, but not as heavy as previously. Correct. Yeah. And not for like each module separately they will give. It's for probably like entire thing, right? Entire support. For IBM. Okay. Which pharma company your client currently? I'm with GSK here. GSK. Okay. GlaxoSmithKline. Yeah. Okay. Yeah, I know GSK. Yeah, so here client office is near to Brentford. So I came in, but anyway, what I'm doing is work from home only. Oh, okay. Did it? Why these are blanks? I think I got missed out. And I guess this was done previous month. Fine, actually. Last week only you have put that range and copied all details. Okay. One second. We have given offset in our forecast profile, I think. I was showing you that, right? Okay. I think, while explaining probably. That's why it is going till 17. I was wondering why it is going till 17. Okay. Let's remove that offset and. Okay. First, let me select my planning area so that half of them will go away. It will be easy to search.
Okay.
Yeah, so I'll just remove this. Just remove this.
Mm-hmm. And even for frozen forecast.
This also. And in outlier, select variance test. And let me save the result.
Okay.
Let me save this result also so that you can
variance,
see.
What is the variance? Sorry, can you remind again?
Yeah, sure. So we have two tests to detect outlier, right? One is interquartile range test and one is variance test. In interquartile, it will draw three quartiles, Q1, Q3, Q1,
Yeah.
Q2, Q3. And it will draw the tolerance bands based on Q1 minus Q3. In variance test, it will calculate mean and standard deviation. Okay. So in variance test, it will draw two tolerance bands. Upper tolerance band is mean minus multiplier into some standard deviation. Lower tolerance band is mean plus multiplier. This multiplier into standard deviation of your this thing. So previously I used interquartile range test to calculate the outlier. Now I'm using variance test to calculate the outlier, to detect the outliers.
Okay.
And I want to save these results also in these key figures so that we can load those key figures and we can see them also.
Okay. Now we can run, I guess.
Okay. Okay, now I will run again and let's see. So this is week 12. So that is why it is not detecting this outlier because it is out of March, right? So we'll put somewhere here.
Okay.
So when I ran with IQ or test also it did not detect outlier. So actually I was wondering. Now it will detect the outlier. Okay. Now I'll save this. Why it did not detect? Because it is not falling in my history bucket. We have put in week 12, right?
Yes. Until week 2.
Now this will detect as an outlier. Okay. Now let us run now. Okay.
Yeah. Week target given.
Okay.
Yes.
So the job will run now. Failed. Wow.
Okay. Maybe something else was open.
I think we have given 5 lakhs, right? I think system.
Oh, is it
unable to. Current period initialized.
Correct forecast model. Abnormal domination.
Correct forecast model 101652, please. What happened with forecast model? Oh, okay. I think we have given that key figures. Actually, we are not using these key figures. Maybe we have not defined in our planning area or something. Okay, so I'll just remove them.
Probably this. Okay.
But what I will do, I will give some other key figure which we can use as a dummy key figure.
Okay.
Or I'll leave it for, okay. Let's remove this because I think that's why it is throwing that error. We have not created these key figures.
Okay.
Okay. Actually, you can give any key figure and you can ask it to save in that key figure. Okay, I mean, system will not understand, right? Whether it is a outlier key figure or substitute key figure, system will not understand it. You can tell any key figure and you can ask system to save it there also.
Okay.
See, troubleshooting means like this only. Actually, in IBP, right, logs are very, very clear. Okay, logs are very detailed. So, if you check even for supply also, and for heuristics or something you run, logs are very good in IBP. You have in heuristics and in optimizer, you have explanation also. If you take that explanation, it will clearly tell you why customer demand was not met or why inventory target was not fulfilled. It will clearly tell you why it did not was unable to meet your expectation. Okay, in the log. So that's one advantage here in IBP. In APO, we are not having that much flexibility in logs actually. So here,
ideally more technical details, I would say.
so IBP is more planner friendly. I mean, and lot of dependencies there on planners. Means how well they are using the system, how they are using, and so the involvement of IT is little less. I mean, configuration and all there will be lot more. Okay.
Yeah.
See, now it has ran. Now let's go to the business log.
Yes.
So now variance test. See, it is telling one outlier found here. See, it actually identified many outliers when compared to IQR test. Okay, because variance test band is small. Okay, IQR band is wide. Okay, so in a variance test, your outliers will be more. Okay, and it have identified our 5 lakhs quantity, whatever we have given, that outlier also it would have identified.
Exactly.
Okay. I just want to show you. Okay, see, it is selling on an average 15-16 outliers it has found happily. Okay.
Yes.
And so what we try to do actually, yeah, we'll refresh now. Okay. And the forecast is calculated now. See, here statistical forecast is very huge.
Yeah.
No, so, I think these.
It's huge values, right?
Yeah, it is very huge. I think probably it have read something somewhere. This 5 lakh something somewhere.
Okay.
Yeah, it read this 5 lakh I think somewhere.
Okay.
Yeah. See, for this combination, it did not read. It calculated correctly, statistical. So this is my statistical forecasting, right?
Correct. Yeah. Here it's fine actually, but
yeah. So here I think we inputted here also wrongly, right? I think it read something and it started generating huge forecast. But for other buckets, it is all good. And we saw somewhere zeros. Customer 3.
But that is filled now.
Product 1, this one. See here also statistical forecasting. Now it got generated correctly. Before it was 0, right?
Yes. Yeah. Now it is generated.
Now it is having values. It is not 0.
Yeah.
Okay. So let us correct this. I want to correct this because we will release this to supply. So I don't want these huge values to come into supply.
Yes, exactly.
So yeah. So what I will do, I will just make these things blank. Okay, and I will rerun the statistical forecast again. Okay.
Sure.
Why, you know why I did not treat this as outlier? Because I have one more 5 lakh, some 50 lakh here in my history, right? So while calculating my outlier, probably it did not, because I have multiple 50 lakh something, maybe it did not treat that as an outlier and it generated. So now let us see, since I have removed those other buckets. Okay, now quickly let us run the statistical forecasting. And see. Okay, it will run. Okay. But did you understand statistical forecasting, how to run the job or create the forecast model? Because
I
planners will come and tell you sometimes to create a forecast model, or you probably need to create them and give them some forecast. They will tell you which strategy they want to use. Then you can you have to select that forecast model, or you can create them with multiple, like I showed you, right? Best forecast model, best fit forecast. You can only create the best fit forecast model and you can give them also. Okay.
Yeah.
Yeah, it is finished. So I'll quickly refresh and see whether system has corrected that. No. Not sure why, what happened.
I guess some more also probably.
No, only for that combination, right? It is not treating that as an outlier. So I'm not sure, need to check. Maybe. You're
I'm available.
no, you're
Sunday, only like late April is go live. So here 1 or 2 days like I need to work.
Okay.
And coming Saturday, yes.
So I will save the data.
Yes. Tomorrow same time is okay for you, 7:30 p.m.
Shall we connect little